Hi, let's talk about simplifying radicals. Now we're going to get into such things as square roots and cube roots. But to start out with, let's suppose that we have a jack-in-the-box here. And now, let's say that this jack-in-the-box is a perfect cube. Let's say that it's X inches on a side. We don't know what it is right now. And to find the volume of it, you multiply the length times the width times the height. And each dimension is the same length. And let's suppose that I said that the volume is 1,000 cubic inches, and I asked, what is the length of a side of this cube? One way of doing this is we can take the cube root of 1,000. It's asking what number times itself 3 times equals 1,000, and it's 10. So that's the length of one of our sides. So we'll be using that idea as we go through here. Let's say we're taking the cube root of x to the 4th. Now what we want to do is find the cubes that are underneath the radical. Now we can separate x to the 4th into x cubed times x. So there's our x cubed. We can pull out an x, and it leaves behind an x, so we get x times the cube root of x. Now this next problem is asking for the square root. For this time we're going looking for squares. We've got a y square underneath there, but that x cubed could be separated into x squared times x. So now we have an x squared and a y squared, so we can pull those out. So we have xy outside the radical times the square root of x. Next one, it's a square root, we're looking for squares. So x cubed is x squared times x. Again, we can pull out an x, and so we'll get 2xy times the square root of x. Next problem here, square root. Looking for squares again. Now that x to the 16th can be rewritten as x to the 8th squared. So we can pull out a x to the 8th. You see, x to the 8th times x to the 8th is x to the 16th. So that's our answer for that one. Next problem, cube root. Looking for cubes. We have a y cubed, that's okay. Now let's look at x to the 15th. That can be rewritten as x to the 5th cubed. So now we have 2 cubes underneath there. Pull that out, we get a negative x to the 5th y. Another problem. Now this one here, there's a negative under the radical. We can't do that one. We can't take the square root of a negative number. There's no root. It's an imaginary number. So we'll go on to one that we can do here. The cube root of 27x to the 9th. Now 27 is 3 cubed, and x to the 9th can be rewritten as x to the cube cubed. So there's our cubes. So we can pull out a 3, and we can pull out an x cubed in this case. Now here's a little technique we can use here. Square root of 3 times 4. You can separate that into the square root of 3 times the square root of 4. And you could further work that down. Square root of 4 is 2, so we can go 2 times the square root of 3. So let's do it the other way. Square root of 2 times the square root of 5 can be written as the square root of 10. So we'll use this in our next couple problems here. So let's try this out. All right, here at the square root. Again, we're looking for squares. Now we can rewrite 8 as 2 times 4, so 4 is a square, and then a squared times a. The a squared is a square, and then we can write b to the 4th squared. So let's take out all the squares and put them in that first radical there, and then take the square roots of them, and so we'll get a 2, and we'll get an a, and we'll get a b to the 4th times the square root of 2a, which is left behind. Let's try the same sort of thing here. We're looking for squares. X to the 4th is already a square. We can rewrite y cubed as y squared times y, and a to the 4th times a. So again, let's pull out all the squares put them in the first radical there and take the square root of them. So we get an x to the x squared, and we get a y, and we get an a squared times the square root of ya. Now, this one here, we're looking for cubes. So we can rewrite a to the 16th as a to the 5th cubed times a, and then we can write b to the 8th as b the squared cubed times b squared. Let's pull out all the cubes. Take the cube root of that first radical there, and we'll get a to the 5th times b squared times the cube root of ab squared. And that would be our answer. Thank you.